is that this distance A, this is the distance A, the focus always lies at a distance AE, 0. Okay. The focus always lies at a distance AE from the origin. Similarly, by symmetry, this will come out to be minus AE, 0. Now I'll try to find out that what is the equation of this directrix. Okay. I know that if this point is moving such that it comes over here, then I know that this upon this ratio will come out to be eccentricity, right? So let's say this is P dash and this is M dash. Now in this case I know that SP dash upon P dash M dash, this is equal to eccentricity. Now what is the distance SP dash? This will be equal to A minus AE. So A minus AE upon PM dash. Now let's say this is X is equal to something. Let's say this is X1. So I can say that X1 minus A is equal to eccentricity. On solving this equation, I will get the value of X1 is equal to A upon E. So I can simply say that the equation of this directrix is X is equal to A upon E. And by symmetry, equation of this directrix is X is equal to minus A upon E. Now guys, one question which arises is, why are there two focus? Why are there two foci of this ellipse? Now see, if this were a center, both the focus would have coincided at the center only. Now as we're stretching this circle, okay, what's happening is these 2 points are moving a little far from each other. Okay, so we'll have two foci which are equidistant from the center, and corresponding to these foci, we will have two directrices. Okay, corresponding to these foci, we'll have two directrices. So now I'll try to derive the result for the equation of this ellipse. But before that, let's first discuss the definition of ellipse. Ellipse is the locus of a point P. So ellipse is the locus of a point P. Okay, this is the point P, which moves such that the ratio of distance from a fixed point, and a fixed line is constant. So this ratio is always constant, then it becomes an ellipse. I will see one more definition of ellipse that I will explain later. Okay, and these two are the basic criterion how we decide that an equation represent or a curve represent an ellipse or not. This is the first definition. Remember this definition. The second definition is more important. Okay, way more important than this one, but you need to remember this one also. And also one thing, that the distance from the fixed point is always lesser than the distance from the fixed line. This FP represents the fixed point and FL is the fixed line. So this distance is always lesser than the fixed line. And this constant is called as eccentricity. So we say that eccentricity is always lesser than 1. So now let's try to derive the result. I will tell you the way how we derive, but I will not do the whole derivation over here. I will just show you how it is done. Let's say this point is x comma y. I know this vertex. So SP will be equal to under root x minus AE square plus y square. Similarly, PM will be equal to, by just applying the thing we used to apply, the distance of a point from a line. By that we can calculate this as x minus A upon E. Right? So if I say that SP upon PM is equal to eccentricity. So if we say SP square is equal to E square PM square, we'll get a result. Something like this. X minus AE whole square plus y square is equal to E square into x minus A upon E whole square. So this is what I'll get after applying the basic definition of ellipse, that the ratio of the distances are equal to E. Okay. Now see that if I try to solve this equation, I will get something like this, that x square upon A square plus y square upon A square into 1 minus E square. This is equal to 1. This is what I'll derive from this equation. I'm not going to do the whole derivation because it's not required, it's not relevant. But you need to know how this equation came. That's why I'm doing this much. So if you open up this equation, you will get an x square term, you will get a y square term. Okay. And after completing the whole squares of that terms, you will get a result something like this. Okay, simple. So if we see this equation, now this thing, when we see that a square into 1 minus c square, when we analyzed this thing, this came out to be the square of this distance. Okay, so we can say that the square root of this distance comes out to be b. Right? So this b is equal to this. So the equation of the ellipse will become x square upon a square plus y square upon b square is equal to 1. So this is the standard equation of the ellipse. Right? X square upon a square plus y square upon b square is equal to 1. Now what are a and b over here? And why did I write this b as here? So we'll discuss this now. Just see that from here, b square can be written as a square into 1 minus c square. And if we try to find the formula for e square, this comes out to be 1 minus b square upon a square. Now by c, e will come out to be under root 1 minus b square upon a square. Now I will not write plus minus because the eccentricity is a ratio of two lengths. Now this ratio can never be negative. So this will always be a positive value only. So the eccentricity comes out to be under root 1 minus b square upon a square. Now we know that this is the part of the minor axis. Now we can say that this b is equal to semi minor axis. You may see some of these terms in some questions, and a is the semi major axis. Why am I writing semi here? Because this is the half of the major axis. So a is the half of the major axis and b is the half of the minor axis. Therefore b is semi minor axis, and similarly this a. Okay. So I can say that eccentricity is equal to 1 minus b square upon a square under root. So if I know the equation of the ellipse, I can easily find the eccentricity of this ellipse. Okay. So this is very important thing. Now see, these vertices, this is one focus and I am denoting this by S dash. The center is just O only. Okay. This I am writing as A and this as A dash. Similarly, this is B and this is B dash. Okay. So we have